Hello everybody, and we're back on what I think may well be the last video in the series of this trivia refactoring. The whole point of the last refactorings was to allow us to have a stack of game states and add a back method to go back, or an undo method to pop the top method, remove the top state from the state stack. So the way to do this would be to have a stack here as being a list of games, and let's just try to use this in a let's just say that the add, rather than taking rather than being a method on game, takes a stack. Let's change all these to stack. And we'll see how to write this to make this work. And let's take the game out of this. Let's say it's going to be the top item on the stack. Okay, so let's find the add method and see how to make this work. We have a stack, which is a list of games. What we're going to be returning is a list of games, and we don't want to just run on a game anymore. Okay, so let's say we just do the following. Me is equal to the top item on the stack. Then we clone it. Then we return stack append of Go syntax isn't particularly nice here. I think that's the right syntax. Yes, it is. This basically says append always takes a list and adds something to the end of it. So there's a discussion to be had in Go as to whether you want the new item to go to the end of this stack, end of the list, or the beginning of the list. Probably be quicker to put it on the end of the list, but I didn't want to write here len stack -1 to get the last element, so I'm just doing it like this now. Let's see if this works, or if I broke something. I haven't broken anything yet. Let's do the same thing for the game method now, for the roll method. So we're going to be taking it out of the answer from the roll method now. And roll is now going to be taking a stack as a parameter. Roll, where are you? Here you are. You're taking a stack, which is a list of games, like this. Okay, and you are going to be returning a stack. So we have me is equal to the stack, the first element on the stack. Then we're modifying me, and we're going to be returning an append me to the, me to stack. It doesn't look very nice, does it? Maybe it'd be worth getting the last item. I've got to change the signature for the roll method here. Let's see if I got that right or I got that wrong. I got that wrong. Yes, we have to clone it somewhere, don't we? No, we're cloning it here. I don't see why this doesn't work. Let's see if I got this right here to begin with. Stack is add, stack is roll, stack game is stack 0. Yes, this is going to be wrong, isn't it? We have to do all these at the same time, otherwise we're going to get into trouble. Because these new games which are coming back aren't being pushed onto the stack, so we can't do it like this. We've got to change all of them at the same time. So let's change all of them at the same time and hope I get this right. If not, well, let's see what happens. Where is wrong answer? Takes a stack. Call it stack, give it a name, and it returns a stack. And the idea is to say me is equal to the first item on the stack. What we're going to turn is a append that's what's coming back, and the same thing for was correctly answered as well. So I hope I'm getting this right, otherwise it's going to be annoying to debug. Game, and what comes back is a list of games, so me is equal to the first item on the stack, and there's two places we're returning here, so we're going to have to do the same trick here. And the same thing here. Hope I get this right. Yes, let's see if this now works, if it's still broken. Yay, it works. Hurrah. I'm actually quite happy about that. I thought I'd most certainly broken it. Okay, so what can we say here about this? Firstly, there's a certain bit of boilerplate here. We're always taking the first item from the stack. Then we're doing something, we're cloning, and then we're returning an appended first item from the stack here. And something else. In this case, false. So there's a basic idea going on here. There's an idea of a with stack, if you wish, or with game. And the function with game takes a stack and a function which takes a game and returns a game. What does it return? It returns, I don't have to name the function, and it returns a new game stack. Oh, sorry, type stack doesn't exist. And the way it does this is it says g is equal to stack 0, and then it says g is f on g, then it says return append game of g stack ... This is what we're doing in all of these functions now which take a stack. Let's see if we can use this with game on our various functions. So we have the first add method here. Yes, this looks to be an easy one here. We need to take the stack first, don't we? And then function, yep, game. Let's call it me because we're using me all over the place here. Back, don't need that. That's what we need. And then return me. And I think we can just shut it here. And that could now work. Yes, it's happy with the syntax. Good, that was an easy one to do. I think we could have problems with some of the other methods. Roll could be more problematic. No, this looks okay. Roll's going to work as well. Return with game stack func. That's the one. Not this one. Let's change it to me. Take that. Put it in here. Return me. And that ends the call. And I made a mistake at the top there, which the language server is telling me about. That looks better. Let's see if this is still running. Or did I break something? That one's okay. I'm worried about the correct answer, wrong answer, because they returned something else as well. Yes, they returned this did player win, or false, or whatever. So it's going to be a more tricky one to change, because the stack just takes the game return to this with game function, takes a stack and it takes a function to change a game into a game, and it doesn't return any information. So there's no did player win, or there's no we don't know if the player won or not. This is a more tricky one to change to use this with game method function on. Let's see if we can find a way to do this. I think that's not the one. Let's take that, put this in here. Let's start to think about this, how to do this. What are we returning here? What has to come back is me has to come back, but we need a way to somehow signify that it's false. So we need a field we need a new field in our game object. And the field could be called last player one. Let's put it in this one into our game object, the game struct. Last player one bool. Let's make it a function out of it. Let's make it a question. Did last player win? Bool. No, last player one's fine. Okay, let's make sure we copy it. Okay, and let's go back to our here. And what we do here is me. We should be okay to just say last player one false. Should be okay. Then we return a me. And then we do the same here. Last player one is equal to did player win p. Then return nope, got to do the next player. Okay, and then when we do here, as the second value we return from this function is we need to take the current stack and get the last player one out of it. Yes, I think that's okay. It's not yet happy with it. What doesn't it like? Oh, I've somehow not got the right formatting, right indentation. What's the indentation that it doesn't like? That seems to be okay. That seems to be okay. With game, func, game. Yes, this looks okay. I wonder what's going wrong. Undefined me. Oh yes, that makes sense. Me is undefined. Last bit was did player win p. I can't spell player. Okay, good. Let's see if this worked, because I'm not so happy about this one. No, it didn't win. Because we are not resetting it in all the right places. Wrong answer. We have to do the same thing. We have to reset it, don't we? Return with game stack func. Let's call it me, just to make sure we're okay. this is, we know the answer is false, but we do have to set me dot last player 1 equals false. We do have to set that, otherwise we're going to be in trouble. Return me. Okay, let's see if this works. If it does, we're now finished with the refactoring. It doesn't work. Oh dear me, what's going wrong here? We're not ending it correctly. Did player win? This looks okay. We're doing this before we advance the player. Then we're setting last player 1. I'm not sure I like this. I'm not sure this is done in the right order, because if this works or not depends upon in which order this is performed. So let's say stack equals, and then return stack comma that. Let's see if that's better. Otherwise it does really depend upon the order it's running in. Yes, that's better. It depends upon if the first return argument was evaluated first or the second one. And that was not good. I didn't know the Go did that. It seems to evaluate the return arguments from right to left, maybe. Yes, I don't like this either, particularly. There's probably a better way to push this information up the chain somehow. But anyway, that's now completed. I suppose there's one thing left to do, which is just to write an undo function. And the undo function is just going to be that. All you need to do to move back once in the history. And you can imagine making this stack a little bit more complicated, to have some sort of pointer in it, so that you can move backwards and forwards. And if you moved back 3 steps and then rolled again and changed what happened in the past, did something different for you to do in the past, then you could delete the future stacks and just add the new future stack, the new version, in their place. So yeah, this is basically how to make this a little bit more functional. As you can see, Go's not the perfect language for this. There's a fair amount of boilerplate needed, these clone with methods, the map index, having to write that yourself. Update current player is quite scary as well. There's a lot going on here. Actually, there's a huge amount going on here in update current player. There's a lot of code to read and understand what's going on. And in other languages, other languages have more syntactic sugar to make this sort of way of writing code easier. I mean, you can do it in Go. There's an example of doing it in Go, but other languages do make this easier from a pure syntax point of view. And I may try to do the same exercise in a language like, I think the good example would be Clojure. I don't think this exercise is available in OCaml. What languages do we have here? Yes, there's Clojure there, which I could try on a later date. There's Kotlin as well, which could be interesting. And there's Racket Scheme. Is there a common Lisp? No, there isn't. Smalltalk could be interesting. So there are a number of languages which may have more or less syntactic sugar to make this way of programming easier. Well, many thanks for staying with me until the end. And yes, I'll see if I can get this done in Clojure as well.